Hello everyone, I'm Sir Saeed. Hope you're doing well. Today we are going to solve a latest paper. It is 9702. It's Feb March and paper 1 2 and 2023. Straight away going to solve. In question number 1, what represents a physical quantity? Physical quantity means we must have a quantity which is measurable and having a specific value with it. For example, 3, we have no idea what's 3. Kilogram is the unit, but how much quantity is with it, we have no idea. 7 Newton is correct because the force and the magnitude and the unit both are given. Question number 2. In question number 2, look at the relation 1 over t is equal to b over under root d plus c. One thing you must know that only those physical quantities are added, subtracted and equated having the same base as a unit. For example, in this the unit of 1 over t is in fact 1 over second, and look at the unit of c here. So the unit of c must be 1 over second, or you can say second inverse, otherwise you cannot add and equate. It means option B or D may be correct. And now you have to write the units for b and under root of d, which must be equal to 1 over second or second inverse. For example, in d, the unit of d is meter square. So with the under root, this is meter square with the under root means it's just meter. So the unit at the top must be a unit after subtracting from meter. It should be the second inverse. So in option B, if we put that unit m s inverse, m is cancelled with this m, so the second inverse is equal to second inverse is added with the second inverse, means option B is correct. Moving forward, question number 3. In this question, a hollow cylinder which is open at both sides means this is a cylinder like this one, and its sides are open like this one. The radius from this point to this r is given, that is 3 plus minus zero point 0.1, and the length, this one which is called L, or you can say H, is 15 plus minus 0 0.1. This area is not included, so you have to write the formula for the surface area of the cylinder. We have two areas. This area is S1 and this area is S2. By adding these two you can get the total area, but this area is not included, and the surface area is 2 pi r h. 2 pi r into h is the area. So by substituting the values, 2 pi r is 3 into 10 is per centimeter, so 3 into 10 per, or even we must leave it with the same unit because the answer is in centimeter square, so leave it, just put the value 2 pi, it's 3 into 15. So by solving this through a calculator, just I have the calculator here, it's 282.7. It's 282.7 means it's 280 by rounding it off. So if you get the uncertainty in these two, these are going to multiply with each other, so straight away the percentage uncertainty in R and the percentage uncertainty in H is, it's 0.1 into 100 by 3, it's 0.1 into 100 by 15. So these two uncertainties must be added to give you the final uncertainty. So uncertainty in small r is 3.3%, and the uncertainty is 0.67%. So the total uncertainty is 4%. So area is 280 plus minus 4%. By multiplying these two and divided with 100 to get the absolute, it is 280 plus minus 10. So option A is the correct one. In this question number 4, the snooker ball is moving towards right with some momentum, going to collide with this one with some hurdle, and its direction is going to change. It's the same ball with the same mass, just the direction is going to reverse. For example, if the ball is moving in this way, its momentum is 0.40 into 0.20. The formula for the momentum is mv, the mass and uh, velocity product, and this is again 0.20 into 0.30, and this is actually the change in the magnitude. So by using the Pythagoras theorem, you may write it as delta p. So the delta p is 0.40 into 0.20 square, the square of the momentum vector, plus 0.30 into 0.20 square, and the under root of this will give you the answer. So after calculation, the answer is 0.10 kg. It's kg meter per second. So option B is correct. Moving forward, for this question number 5, a ball is kicked upward at an angle of 45 to the horizontal ground. After a short flight, the ball returns to the ground. Means it's a type of a projectile. It's like this one. This is the motion of the projectile. This angle was 45 degree initially. So it may be assumed that air resistance is negligible. What is never zero? Never is bold here. What is never zero during the flight? You know that in the projectile motion, initially the body is moving in this way, so it has the horizontal and the vertical component of the velocity, like this one, like this one. Here we have the vertical velocity here, the vertical velocity, but at the top there is no vertical velocity. So the vertical component of the ball's momentum never be zero, so it's zero at the top, so it's wrong. Same with the velocity. The horizontal component of the ball's acceleration remains zero because its velocity is constant along x-axis, so it's wrong. The horizontal component of the ball's velocity will never be zero, it remains constant. Say it's 10 here, it's 10 here, it's 10. It's never be zero at any point, even at the top. The horizontal velocity remains constant. Look at this question. In this question is actually a graph between the displacement and time. The gradient gives you the velocity. Gradient gives the velocity, or the slope gives the velocity. Here the slope is positive and uniform. Here the slope is negative and uniform. It means the slope is uniform for the velocity, and if the velocity is uniform, it means there is no acceleration. So option D is like this one. It's this one. Option D is the correct option, because the acceleration is zero at this point. Acceleration is zero at this point, it's zero at this point. So for all the slopes, the acceleration is zero for all the slopes. But here The acceleration is varying wrong, the acceleration is constant wrong, the acceleration is constant wrong. The acceleration must be zero because the velocity is uniform, and the velocity is actually shown by the gradient of the displacement time graph. Sorry, this the last graph is behind this picture. In fact, question number 7, it's a simple definition. Which expression defines the force? You know that the rate of change of momentum is equal to the force. So change in momentum over time taken, option C is correct. Look at here. There is a ship and the mass of the ship is 8.4 into 10 raised per 7 kg, is approaching towards a harbor. This is, you can say, a harbor with the speed of 16.4 meter per second by using a reverse up thrust. The reverse thrust, not up thrust, it's the reverse thrust, is actually a force, this one, and this remains constant. How long it takes to stop means at this point somewhere its velocity become 0, and here its velocity is 16. So it means the opposing force is acting on it, the velocity is going to change, it means there is a change in the momentum. So F is mv minus mu over t, this is v. It's 1, 2, 3, it is mass 8.4 into 10 raised per 7 multiplied with 16.4 minus 0 divided by time. So by cross multiplying the time, which is already calculated here somewhere, yes, this time is 1497.7 seconds. By converting it into minutes, we come to know that's 25 minutes. So option C is correct. Moving forward, in question number 9, all these graphs are the velocity time graphs. Which graph represents uh, an object falling from rest through a long distance? Long distance means more height, and the height or the distance is being calculated by the area under the graph. So you come to know that this area, if we compare this area, this area, this area, and this area, we come to know that this is the largest one. Bigger area, large area. Large area means more distance, so option D is correct. Simple question. Which statement about collision is correct? Kinetic energy is conserved in all planes, no. Momentum is only conserved in the elastic, no. The relative speed of approaching is equal to the relative speed of separation for perfectly elastic collision. Yes, it is correct. This is the basic definition for the elastic collisions, in which the sum of the approaching velocities is equal to the sum of the separating velocities. So in question number 10, option C is correct. On the next slide, in question number 11, this diagram is a little bit complex, but the question is very simple. In this question, this force is acting downward here, but if we see from the top, these two forces are equal and opposite and acting on one body. It means you can get the torque, or you can say that the couple of the torque, it's like this one. It's like this one. One force is here, the other force is somewhere over here. So two equal and opposite forces acting on one body. So the net force is 0 because the sum of up and the downward forces are equal. So there is no resultant force. Option A and C. But if we get the torque, you know that for this torque, this is 2rf. So 2r is the distance between the forces, which is 2.3 plus 2.3, it is 4.6 meter. So 4.6 multiplied with 40, the answer is 184. 184, which is rounded to two significant figure, it's 180 Newton meter. So option C is correct. Next question is question number 12. Look at this question. We have two pictures. These pictures are same. Same pictures means they have same weight, which is downward. If they have same weight, it means they are being balanced by the same type of upward forces. So R1 and R2 must be same, like their weights are same. So option A or B is correct. But you know that they have different angles. These tensions in the string have different angles, means that these two tensions are not equal with each other. That's why option B is correct. This is the shortcut to solve this question, but you can get this comparison between the tensions by having some angle over here. You know that there is some angle theta here and there is some other angle theta here. If we divide it into the components, we have these components, like this one. So this is called T2 cos of theta, and here we have T1 cos of theta. You know that uh, cos 0 is 1 and cos 90 is 0, means when the angle increases, the answer decreases. Here the angle increases, so this value decreases, means T2 become less than T1. So option B is correct. Now this question, I have just to write this option. The last option in question number 13 is 2 by 3 rho r g. This is option D. Now, an object shaped as a hemisphere rests on the flat surface. The object has radius r. The volume of the sphere is 4 over 3 pi r cube. We are going to solve this question. Volume is 4 over 3 pi r cube, but for this particular body, this is a hemisphere, means half of the volume is required, so divide this volume with 2. Hence V is equal to 4 over 6 pi r cube is the volume. So the formula for the pressure is F over A. This is the area which is in contact here. If we see the from the bottom of this hemisphere, the area must be like this one, which is equal to pi r square. Anyhow, this force is mg and area is pi r square. You know that this mass is volume into density over pi r square. So by substituting the values, V is 4 over 6 pi r cube, this is volume, rho g over pi r square. This pi is cancelled with this pi, this r square is cancelled with this cube, and this is 2 by 3. So the answer must be 2 by 3 r rho g. Option D is the correct answer. Two tricks in this question. Initially, this is a hemisphere, so the volume uses half of the volume of the sphere, like this one. And the second thing, the area which is in contact with the table is actually like this one, so this area in contact is pi r square. Moving towards question number 14. In this question, a probe is used to monitor the quality of the water in the sea. The probe is suspended vertically like this one. The stationary sphere floats in equilibrium on the surface of the sphere. The weight of this sphere is 5 Newton, and the probe and the string has combined weight of 2. So the total weight acting downward is 7 Newton. It means if it is floating, the upthrust acting is 7 Newton as well. But this upthrust is acting only for this half of the sphere because it is inside the water. The density of the seawater is given, the upthrust acting on the probe and the thread is negligible. Okay, the upthrust is acting on the sphere only. What is the volume of the sphere below the surface of the water? So if we know that the pressure is equal to rho gh, and if there is a change in the pressure, then you can get the upthrust F is equal to delta P into A. So F is equal to rho GHA. This HA is actually the volume which is shaded here. This one. This is H, and the area gives you the volume. So F is equal to rho GV, and this V is in fact F over rho G. The F is the upthrust force because of the pressure difference, which is 7 Newton. So the density is 1.03 into 10 to the power 3 multiplied with 9.81. By substituting all these values in a calculator, you can have this answer. Is 6.93 10 to the power minus 4. 6.93 into 10 to the power minus 4 meter cube. 6.93 means option D is the correct one. So in question number 15, it is the basic definition of the center of gravity. You know that the point where the whole weight of the body is going to be act. The point at which the weight of an object may be considered to act. Option B is correct for question number 15. 14 is done as well. Moving towards question number 16. A system with an efficiency of 74%, waste is 230 watts for the power. What is the useful output? So for the simple formula, you know that the efficiency is useful output over input into 100. The efficiency is 74 by 100, which is 0.74, and the output is required. The output is required. So the input is actually going to convert into the output and some waste. For example, if we give some input to a system, there is some output and some waste. So if we add the output and the waste, we can get the input. So here the output is not known, and we add the waste here, and the waste is 230. So by cross multiplying, it's 0.74 into output plus 0.74 into 230 is equal to output. So by solving this relation, you come to know that the output is 650 here. So option C is correct. In this, a projectile of mass, this is at the height, means this is some surface, and this is certain height at which we have the projectile. 30 meter above the surface. Its mass is 0.25 kg. Above horizontal ground are traveling at a speed of 15. Okay, a short time later it is at a height of 35. It means it comes to at this point at a certain height somewhere over here, and this height is 35 meters. Okay, and the speed at this point was 15 meter per second, and at this point the speed is 5 meter per second. So you have to find the work done against the air resistance. So if we follow the law of conservation of energy, there is some height gained by the projectile, and if it is gaining some height means gaining some potential energy and gaining the kinetic energy as well. Ideally these two must be equal. The gain in the kinetic energy is actually the loss in the potential energy, or the gain in the potential energy is the loss in the kinetic energy. But if there is some difference between these two energies, that energy or the work done is used to overcome the air resistance. So straight away going to solve this problem by having the relation mgh. We know that the mass is 0.25, it's 9.81, and the height is just 5. It will give you some answer, and this answer is, if I have written somewhere over here, yes, it's 12.26. It's 12.26 joule. And for the kinetic energy is half mv square, v square for 15 square, plus half mv square for 5 square. By solving this, the answer is 25 joule. It means these two are not equal with each other. The gain in the potential and the loss in the kinetic are not equal. So the remaining energy is used to overcome their resistance and friction. So by subtracting these two values, you can get the answer. So the work done must be equal to 25 minus 12, or 12.26. The answer is 13. It is in fact 12.7, which is rounded off to be 13 joule. Option B correct. Hopefully you are getting the concept of this question number 17. Now look at this question number 18. Here we have a spring which is unstretched. The spring is like this one. It was initially unstretched and its length is 4.5 centimeter. So a spring is fixed with one end from this side, and there's a force applied on it, and this force is 35 Newton, and there is some definitely extension in the spring. It follows Hooke's law, means this is going to extend within the elastic limit, and the spring constant is given. So you can get this E, because the strain is required, and this strain is in fact the ratio between the change in length and the original length. So the original length is given here, we just find the change in the length. So F is equal to KE, then E is equal to F over K, and F is 35 while K is 220. So the answer is 8.3 centimeter. I converted it into centimeter. In fact, it is 0.083. So by substituting value here, it is 8.3 centimeter. This is 4.50 centimeter. So by dividing these two, we come to know that the answer is 1.85 without any unit, because it is the ratio between two same physical quantities. Option C is correct. Moving towards question number 19. Look at this question. These arrows shows that when the force is applied on some body, there is some extension and the graph comes to at this point. And when the force is removed, it comes back to its original position, means there is no permanent deformation because the extension is zero after removing the force. Which statement describe the deformation? Both elastic and plastic? No, it was not in the plastic. Plastic means the permanent deformation. It elastic only? Yes, it is looking correct. It is neither elastic or no, it's wrong. It's plastic only, wrong. Option B is correct. It is within the elastic limit, means it comes back to its original position without any permanent deformation. This particle is at point P and this particle is at this point Q somewhere, and these particles are going to have the vertical motion like this one, and this particle have vertical motion like this one, but whatever their motion have, the angle between these two particles remains constant. The angle is not going to change because both are in motion, so there is a constant phase difference maintained between these two particles. Option D is correct statement. So it's a long question, but in fact it's a simple question with a simple concept. In question number 21, which statement about the longitudinal wave and the transverse wave is not correct? Both waves can be polarized. Okay, this is not correct because you know that the transverse waves can be polarized, but we cannot polarize the longitudinal wave. So option A is straightaway correct. Both waves can form stationary waves. Both waves are transverse energy is correct. Both waves obey this formula. Okay, all are correct. This is not correct. Question number 22. An observer hears a sound from emitting from a moving source. The observed frequency is less than the frequency of the sound emitted from the source. What could be the reason? It means there is source S and this is some observer. The observer hears the sound emitted from the moving source. The observed frequency is less than. If the observed frequency is less than, means the source is moving away. The source is moving away like F naught. The observed frequency is V over V plus Vs into F. This F naught is going to decrease. So the source is moving away from the observer. Yes, it's right. Question number 23. What is the approximate range of the frequency of the electromagnetic which is visible to the human eye? So you know that the visible spectrum, the range of the visible spectrum is from 400 nanometer to 700 nanometer. If you calculate it by using the formula F is equal to V by lambda, then this is 3 into 10 raised per 8 and the wavelength is 400 into 10 raised per minus 9. You come to know that the answer is 3 over 400 into 10 raised per 17. So by using 750 into 10 raised per 12 hertz, which is 750 terahertz, it means this option is looking correct. Yes, it is. And if you want to get the other answer, you just use the same formula with the value of 700 nanometer over here. So option D is correct. Moving towards this question. This question is little different from the previous question because we have just one filter here attached. So if we have this beam of vertically polarized light having some particular intensity, you can say I naught, and at this point we have some new intensity I. In this question, the filter is first rotated clockwise by an angle of 30 degree, so that the transmitted wave has the intensity I30. So this is the transmitted one. I30 is equal to I naught cos square of 30. Now the same filter is again rotated clockwise further 30. So it means when we rotate it further, initially it is I naught, but now it comes to I naught cos square of 60. Now this is the new transmitted one that is called I. Now you have to write the new intensity of the transmitted wave. You have to write this new one. So if we have to look in these answers, all answers are in terms of intensity when the angle was 30. So if we divide these equations, then I is equal to I naught cos square of 60 divided by I 30 over I naught cos square of 30. Then this I naught is cancelled because it's not going to use anywhere. So by having calculated the cos square 60 is 0.25, 0.25, cos square 30 is 0.75. This is I over I 30. By dividing, the answer is 0.33. So I is equal to 0.33 I 30. So option B is correct. Again, the incident intensities I naught, so for angle of 30 degree we have this relation and the intensity is called I30. We have same filter, it's again rotated more angle of 30, so the total rotation is 60, hence this new intensity is to be obtained by I naught cos square 60. So by dividing these two you can get the answer. Question number 25. In this question, initially you know that if the stationary wave is formed inside the instrument, we may have the node and the antinode here. So it means if its length is, you can say, L, and this is called lambda by 4, then L is equal to lambda by 4. Lambda is equal to 4L. So the frequency is F is equal to V by lambda. Then V by 4L is equal to 92 Hertz. It's given. For the next diagram, we have a complete loop and the half loop, means it's 1, 2 and 3. The length is 3 lambda by 4. So the new frequency is V over lambda is 4L by 3. So the answer is 3 into 92. Further we have 5 into 92, then we have 7 into 92 and so on. So if we multiply 92 with 3, the next option is 276. And if we multiply 92 with the 5, have just calculation here. It's 460, yes it is. 460. So option C is correct. Okay, in question number 26, two waves of equal frequency and amplitude travel in opposite direction, means they are going to produce the stationary waves. When they meet, they form a stationary wave with three nodes and two antinodes. Three nodes means it should be like this one. Here we have three nodes, this one, this one, and we have two antinodes like this one. Okay, and this is equal to one wavelength called lambda. The frequency of both wave is double. Okay, the frequency is double means from the formula you come to know that V is equal to F lambda. If the frequency is double, the wavelength should be half. So if we half the wavelength, it means for this lambda we have one wave or two loops. Instead we must have four loops here because the wavelength is reduced. This is now equal to lambda. So here we have to write the number of antinodes. Antinodes is 1, it's 2, it's 3 and 4. So option D is correct. Question number 23 is a very simple question. You know that the waves coming from the transmitting mast is going to have the diffraction here. That's where it's going to bend to be received at this point. So this question is straight away related with the diffraction. The radio waves are diffracted. Yes, B is correct. While the microwaves are not, the diffraction depends upon the obstacles of the gaps. The waves are emitted from the two coherent sources. Coherent means constant phase difference. Constant phase difference means they must be uh, having the same angle between these two. They have the constant phase difference. So option C is correct. You have to see this question. This is the diffraction grating. Yes, right. You know that n is the number of lines per centimeter or millimeter. A is the any two adjacent lines are at a distance of A. Okay, and it's D in fact. Okay, any two adjacent lines are at a distance of D apart. That is d sine theta is equal to n lambda. Okay, a beam of the parallel light, wavelength lambda is incident. This lambda is the incident one, and the distance is L between the diffraction grating and the screen. Which quantities affect the distance between the first order maxima on the screen? First of all, you have to see these angles. If this angle is going to change, means this first order and this first order is maybe getting close to each other or moving away. So one thing is related with this angle, and the second thing is the most important. If we move the screen away or we move the screen towards, means we change this length, this angle will definitely going to change. So initially this L will affect the distance between the first order. So option A or option C must be correct, and option B and D are wrong. Now the second thing is to change this angle is D. Definitely if we change this D, the angle is going to change, and this is constant, order of diffraction remains 1, and if we change the wavelength we can change this angle. So D and lambda must be changed. Option A is the correct one. A wire carries this current, the potential difference is this one, how much energy is going to dissipate. So E is equal to PT, or you may write it as VIT to get the energy. The voltage is 10 into 10 is per minus 3 for the millivolt. For micro, 0.10 into 10 is per minus 6, and the time is 10 seconds. So by solving this, you come to know that the answer is 10 nanojoule. Let me confirm I have already solved it by using the calculator. Yes, it is 10 nanojoule. Option D is correct. And this question, what is the potential difference? You know the basic formula, V is equal to W by Q, the work done on the energy per unit charge. So the energy transferred per unit charge, option A is correct. In question number 32, first of all you have to look the filament of a lamp. So this graph is for the constant resistor, wrong. This is for the diode, wrong. There's a confusion between these two. When the voltage increases, the filament is going to heat up by the heat. The resistance increases and the current decreases. So the current is decreasing in this one. So option B is correct. This is valid because the filament of the lamp is made by a conductor. In question number 33. The table shows the properties of the two different wires P and Q. We have a wire P and another wire Q. The P has a cross section of diameter D. What is the diameter for Q? You have to write the diameter for this one. So initially, if we write the relation, that is R is equal to rho L over A is pi D square by 4. Look at here. In fact, the cross-sectional area is pi R square. Then R is equal to D by 2. So you may write at D square by 4 over here. And for this, we have R here. This R is now for Q R by 4. This rho is 1 by 3, okay, and the length is 2L, 4, this is pi, and this is D dash square. This D dash is required. So generally we have this formula, that is R is equal to rho L over A, and this is modified by having these properties of the wire Q. The length is 2L, the resistance is 1/4, and the resistivity is. So this D dash is required here. If we put this value of R over here, or you put, or just compare these two by any means. Look at here. If we may write it as R by 4, this R by 4 is equal to rho L over pi D square. So the left sides are equal, you may compare the right sides. So this is equal to rho L over pi D square is equal to 6 rho L over 3 pi D dash square. This rho L is cancelled with rho L. This pi is cancelled with this pi. So D dash square is equal to by cross multiplying D square 2 I think there is some mistake. Yes, it is. This is 4 2s are 8, so this should be 8. So it is 8 by 3. By taking the under root, the D dash is equal to D, and the under root or the square root of 8 by 3 is 1.6. So this B is correct. We use the simple basic technique. Initially write the relation for the wire P, then modify it for the Q, and just making the left side equal, the right become equal with each other, and after crossing and cross multiplying you can get this answer. Question number 34. A cell has a constant EMF, yes it is. A variable resistance connected between the terminals. Okay. The resistance of the variable resistor is decreased, which statement about the change of the cell's terminal potential difference is going to change? And if we have this cell, its EMF is E, and there is some internal resistance R, and attached with the external variable resistor like this one, the terminal potential is V against this resistor. The variable resistor is connected. The resistance of the variable resistor is decreased. It means if we decrease this resistance, the voltage is going to decrease here. So if the resistance decreases, the voltage decreases over here. So the voltage against the internal resistance must increase, because the sum of these two voltages must be equal to EMF. For example, this EMF is constant, it's 12 volt, for example. And if we decrease this, and suppose this voltage is say 4 volt and this voltage was 8 volt, so the sum is 12. If we reduce this resistance, this voltage reduces to maybe 6 volt. So 6 plus 4 is 10. It means this voltage must be increased to 6, so their sum should be 12. Means the voltage against the internal resistance increases. Voltage increases means more work done on a charge. So the terminal potential difference is decreased, yes, because more work is done moving a unit charge through the internal resistor. Option A is correct. In question number 35, this is actually the basic definition and some properties of the Kirchhoff laws. For the Kirchhoff current rule, the charge is conserved, and for the voltage rule, the energy is conserved. So from the knowledge, we come to know that option B is correct. In this question number 36, look at here. We have a cell, its EMF is, you can say, 10 volt, internal resistance is given, the value of internal resistance, and this resistor R is not known. But you can get the voltage over here, because the terminal voltage is IR. This voltage is 0.48 into 15. So by using the calculator, 7.2, it is 7.2 volt. It is 7.2 volt here. So the current flowing in this is 0.48, 0.45. So the current flowing from the cell is the sum of these two currents. So 0.48 plus 0.45 will give you 0.93. So the current is 0.93 ampere. So the current is shown over here. If this is 7.2 volt and this is 10 volt, these two must have combinedly 7.2 volt, and the voltage against this resistor must be the difference of 10 and 7.2. It's 2.8 volt, because you know that E is equal to V plus IR. So V is 7.2, IR is 2.8, that's why the EMF is 10. So if the voltage of this internal resistor is known, you can get its value. V is equal to IR, then R is equal to V over I. The voltage is 2.8, the current is 0.93. So the small r is 14. So option A or C is correct. No, it's not 14. It's not 14. Just divide it again. 2.8 divided by 0.9 is 3. Sorry, it's 3. So yes, option A or B is correct. Internal resistance is 3, not the external one. So look at here. We come to know this resistance. This is in fact V is equal to IR. The voltage is 7.2, the current is 0.45, and the resistance is R plus 2. By solving you can get R, and the value of this R is 14 ohm. So option A is correct. In question number 37. A battery of negligible internal resistance, yeah, right, it is connected in series with the thermistor and a fixed resistor of 12 kilo ohm. Okay, the table shows the resistance of the thermistor for two different temperatures. At 20 it's 12 kilo ohm, and at 50 degree it's 5 kilo ohm. The potential difference V out across the fixed resistor is 4.5 when a thermistor is at a temperature of uh, 20. If the thermistor is at 20, it means the resistance against this is 12 kilo ohm. And when it is 12 kilo ohm, and the potential difference V across the resistor is 4.5 volt. If it is 4.5 against 12 kilo ohm, then it is 4.5 over here as well. So both resistors have the same resistance. If one's having the potential of 4.5, the other must have the same potential. So by adding these two, we come to know that the applied voltage or the EMF is 9 volt and it's fixed. Now you have to get that what is the V out when the thermistor is at the temperature of 50. So if temperature is 50, then um, the resistance is 5. So if this resistance is changed to 5 kilo ohm, and then by using the potential divider, V is equal to 12 kilo ohm divided by 12 plus 5 into EMF is 9. So by solving this on calculator, you come to know that it's 6.35 volt. So option C is correct. The units are not being changed because the units are going to cancel here. For question number 38, what is the conclusion from the alpha particle scattering experiment, the gold foil experiment? The protons and electrons have equal. No, the protons have a much larger mass. No, there's nothing to do with the protons. In fact, the nucleus contains the most of the, yes, right, the most of the mass of the atom is concentrated inside the nucleus. This is one of the property of alpha scattering experiment. Over here the alpha is going to emit from americium 241. So this 241 minus 4 and this 95 minus 2 give you the property. So 241 minus 4 is 237 here, and 92 is 93. So option A is correct. It's a simple question. In question number, this last question, a top quark having the charge of plus 2 by 3 E is the basic charge of the proton, you know that. What is the charge of an antitop? Antitop means the antiparticle. So for the antiparticle, the charge is same in magnitude, opposite in the numeric value. So 2 by 3 E is same, but this positive must be negative. So option A is correct. Thank you very much and good luck for your exam.